In this video, we will talk about Java Collection, or also known as Java Collection Framework. Before we understand the Java Collection Framework, we should cover the basics of data structures. What is the data structure? The concept of data structure is to basically organize the data. With the help of data structures, we store the data, we process the data. You might be aware of different data structures like arrays, stack, queues, maps, and each of these data structures, they organize the data in a different way. When we need the data to be stored in the contiguous memory locations, we use array. When we need LIFO behavior, last in first out, in that case we use stack. When we need FIFO behavior, first in first out, then we use queues. Or whenever we need the dictionary type of mapping, then we use maps. So how does it relate to the Java collection? To understand that, we need to understand how do we store the data, whether it is temporarily or for the long term. We need to understand the concept of variables. So we use variables in the most basic form. We use the variables to store or to hold the values. All right. And that is common in all programming languages. They support variables, and that's how we hold the values. They are basically the holders, whether it is primitive or reference, method, local variable, or instance or static, whatever it is, the idea remains the same, to hold the values. Now consider the example. We have an employee class in Java and we need to store a single employee object. How would we do that? To do that, we straightforward know that we will create a reference variable of type employee, and we will simply assign or use this syntax to create the new object and to hold that new object in the reference variable E1. So here we are storing the data temporarily, and later we can use operations on the E1 to do some basically maybe state changes on the employee object. All right, is probably the most basic way to store the data. It does not have any specific behavior like stacks or queues. It simply stores the data. It simply stores primitive values or reference values, which is objects. Now think about it. Now let's say we have to store 100 employees. How would we do that? Creating 100 employee variables is not the most efficient way. So what we will do, we will create an array of type employees, an array of size, let's say 100. Now the thing with the array is that we need to provide the size. We need to provide the size because arrays are fixed with data structures. They need to know the size. And here we provided 100 because we know that we have to support 100 employees. We have to store 100 employees. Okay, so as long as the size remains the same, there is no problem. But in the real world, consider the scenario where we need to store, for example, 101 employee objects. So when we started writing that code, or when the code starts its execution, the size was supposed to be 100, but later during the execution, let's say it generated a new employee object, an additional employee object, 101. Now how do we solve this problem? To do that, we'll have to code the situation in such a way that create a new array, okay, of size 101 and copy all the 100 elements from the old array. That's what we need to do because arrays are fixed size data structures, and earlier we had an array of size 100 which actually had 100 employees, but now because we need to store an additional employee, so we have to create a new array of size 101, and we need to copy all the old elements from the old array. So you get the idea, this is an overhead. Because if this size keeps increasing, then we'll have to keep creating new array objects, and it will have the overhead of copying all the old objects from the old array. So you understand the overhead of creating the new array with the new size and copying the elements from the old array. That is the problem with the array data structure. Whenever we need the dynamically sized arrays, then array is not the basically it's not the best way to go about it. Similarly, think about it. What if we need a stack like data structure? How would we do that using variables and arrays? Or maybe how do we implement a map kind of data structure in Java? So obviously the one way would be to develop everything on our own. Maybe we'll write our own stack classes and map classes to use or to solve these problems. But there is a better way, and that is the concept of Java Collection Framework. So Java Collection Framework is basically a set of interfaces and classes provided in the JDK itself, shipped with the JDK, which provides implementations of various general purpose and special purpose data structures, so that we don't have to write data structure on our own. So think about stacks, it's already there in the Java Collection Framework. Talk about map, it's also there in the Java Collection Framework. So we don't have to reinvent the wheel, we don't have to develop everything again. It's already there in the JDK, in the API, and we can simply use it. That is the concept of Java Collection Framework. So let's move on and take a look at the Java Collection Framework. What kind of classes are there? What kind of data structures are there? So this is a very basic outline of Java Collection Framework. So here we see this is basically an interface, the root interface of the Java Collection Framework. Then there are interfaces like list, set, queues, and map. Now list is a data structure, and we have different types of lists supported in the JDK. Array list is an example, linked list is another example, vector, copy on write array list. There are basically many types of lists that we can use. We don't have to develop them on our own. We can simply use them for the problem that we are solving. Similarly, for the set, we have hash set, linked hash set, and tree set. Coming to the map, there are various implementations of map data structure. Hash map is one. The most common type of implementation is hash map. Linked hash map is another. If we need to use the sorted map, then we can use the tree map. Hash table is a legacy implementation. Concurrent hash map is another very popular hash map, specific to the concurrent problems when there is multi-threading involved. We have many types of queues. For example, deck is supported in the Java Collection Framework, array deck, concurrent linked queue, blocking deck, priority blocking queue, synchronous queue, many types of queues. It is overwhelming, but what we need to understand is all these data structures are already there, developed by the Java language designers, and they are well tested, and it is all there in the JDK API. So we don't have to write these all data structures on our own. That is the best thing. We will cover all these data structures one by one with examples how to use them, and for some of them we'll also take a look at the source code of the Java API in order to better understand the behavior and the performance of these data structures. Now if we want to look at this framework from another angle, then this is another outline of the same thing. So there are key interfaces in Java Collection Framework. These are all interfaces, Java interfaces: collection, list, set, map, queue, deck, blocking queue. Then there are general purpose implementations of these key interfaces that we already talked about, array list and linked list. These are the implementation of list interface. Then hash set, linked hash set, tree set are the implementations of the set interface. Then there are special purpose implementations specific to, we will talk about these scenarios, but copy on write array list, copy on write array set, then these are concurrent implementations. If we are trying to solve a concurrent problem, if we are dealing with multiple threads, then it's better to use one of these data structures or collections, for example, linked blocking queue, delay queue, concurrent hash map. All right. Then there are utilities classes in the Java collections framework. Collections is a utility class. Arrays is another utility class to deal with the arrays. Infrastructure means how do we iterate on these collections. So there is this iterator interface. How do we sort them? To sort them, we can use comparable and comparator. Random access is another interface that basically makes it possible to access the locations in a random way. For example, array supports random access. So in order to access any index in constant time, it's possible with arrays, right? So that sort of thing. So here we talked about Java collection framework from a very high level, and in the future videos we will try to cover all these important Java collections one by one with their important methods and their behavior. All right, stay tuned.